the new 1996 Ford Fiesta. This program introduces you, the Ford service technician, to the new model's technical specification and takes a look at key service implications that may affect you in the workshop. This new Fiesta has a choice of 4 engines, 3 petrol units and 1 diesel. The Endura E 1.3-litre petrol engine, although looking familiar, is actually a substantially uprated version of the proven HCS engine. Power output is impressive, the unit developing a maximum 44 kilowatt at 5,000 RPM. Maximum torque of 103 Newton meters is developed at just 2,500 RPM. The Endura DE 1.8-litre diesel is another unit that will look familiar, but again it's been substantially uprated. Maximum power of 44 kilowatts is developed at 4,800 RPM, while maximum torque of 105 Newton meters is achieved at just 2,500 RPM. The other 2 petrol engines are completely new designs and outwardly almost identical. Known as the Zetec SE engines, there's a 1.25-litre version and a larger 1.4-litre, the E denoting the emission standard each engine meets. The 1.25-litre unit develops maximum power of 55 kilowatts at 5,200 RPM. Maximum torque is a useful 112 Newton meters at 4,000 RPM. The larger 1.4-litre version develops maximum power of 66 kilowatts at 6,000 RPM, while maximum torque of 124 Newton meters is achieved at 4,000 RPM. 4 excellent power units for this new Fiesta, about which we'll hear more later in the programme. Fiesta 96 offers a choice of 2 different transmissions, a manual and an automatic. Fiesta's manual transmission is an uprated version of the B5 unit, to be known as the IB5. Alterations have been made to the gearshift mechanism to ease changes and prevent gear lever rock as engine load fluctuates. First, second and third gears now feature double synchronization for smooth, precise gear changing, and the bearings for the input and output shafts are now sealed. The synthetic transmission fluid used in this unit must not be mixed with other gear oils. Furthermore, the fluid level must be maintained at 10 to 15 millimeters below the filler plug. This IB5 transmission is operated via a hydraulic clutch mechanism that works in similar fashion to that on Mondeo and Scorpios with the 2.5 TCI diesel. The clutch slave cylinder and clutch release bearing are combined as one unit, although the release bearing can be replaced separately. A pilot pressure valve keeps the slave cylinder under permanent pressure, so that the clutch release bearing is in constant contact with the clutch pressure plate. If being replaced for any reason, this valve must not be over-tightened. This may cause malfunction. Next to the pilot pressure valve, a bleed nipple that allows you to bleed the hydraulic system in the usual way. As to clutch pedal travel, this is adjusted by means of a stop screw on the pedal bracket. Accurate adjustment is essential for correct operation of the clutch master cylinder. Details of the required pedal travel are contained in your service literature. The automatic transmission available on this new Fiesta is an uprated version of the ingenious CTX. One obviously new design feature is the straight shift gate, making operation much easier. The planetary gears have been redesigned. There's a new clutch lining material and revised clutch application curve. In addition, there's a new steel drive belt. It all adds up to a substantially improved drive performance. An important service point is that the procedure to fill the unit with the specified lubricant has been revised. Fluid changes are required every 45,000 kilometers, and you should check the new filling procedure in your service literature. A final point concerning Fiesta's drive transmission to the road wheels: the outer drive shafts are now equal in length to avoid any torque steer effect under heavy acceleration. The front suspension on this Fiesta 96 has a number of new design features. It's now assembled around a front frame in similar fashion to Mondeo. The L-shaped suspension arms controlling the positioning of the driven wheels are made from high-strength, low-alloy steel. The vertically mounted rear bush and horizontally mounted front bush are also new designs. As to the Mk4 struts, these have been redesigned in the area of the upper mount to ease steering effort. In addition, the lower spring seat has been offset by about 27 millimeters. Because a stabilizer is fitted as standard, the spring rates are up to 20% softer. The rear suspension remains largely unchanged, except for the bushes in the forward mounts of the twist beam axle. These have been redesigned to achieve a self-stabilizing and toe-correcting effect. This reduces slip angle and helps to improve tyre grip. There's a special procedure for replacing these bushes, which is detailed in your service literature. As to steering on this new Fiesta, this shows little major change. The rack and pinion system is bolted to the front frame assembly. The steering column now has two universal joints to minimize the chance of column penetration during a frontal accident. Power steering is now a standard feature on some models, optional on others. The brake system on Fiesta 96 sees a number of new features. In general, the system will be familiar, with drum brakes at the rear, disc brakes at the front. The disc brakes are a new design with single piston sliding calipers. The discs themselves have also been increased in thickness to 12 millimeters. ABS is available as an option on Fiesta 96. It's the 4-channel Teves Mk4 system similar to Galaxy. Traction control can also be specified as an option. The system is fully controlled by its own electronic module, this module controlling traction control as well if fitted. The ABS unit is located in the engine compartment and combines the hydraulic unit and electronic module in one assembly. There are 4 wheel sensors, one for each front wheel, one located in the back plate of each rear drum brake to monitor rear wheel speeds. From the signals received, the electronic module can detect any tendency towards brake blocking when the brakes are applied, or any wheel spinning under acceleration. The module then instructs the hydraulic unit to release or apply the brake for the wheel or wheels affected. This ABS system also includes electronic brake force distribution according to the load in the vehicle. In the event of failure to either system, there's a warning light on the instrument panel for ABS and a separate warning light for traction control. Fault codes will be stored in the module's electronic memory. Connecting FDS 2000 to the data link connector enables the codes to be recovered and diagnosis carried out. Other service work on Fiesta's brake system will be largely familiar. 2 points should be remembered. To remove a rear brake drum on vehicles with the ABS system, you must first remove the wheel sensor from the backplate. Thereafter, the 4 securing bolts holding the drum and spindle can be released, and the spindle assembly removed. As to the handbrake, there's a new and quicker adjustment procedure which can be carried out from inside the vehicle. The brake pedal first needs to be applied several times to locate the brake shoes. Then, after removing the gaiter covering the handbrake mechanism, the adjuster screw should be turned so that the handbrake can be pulled no more than 6 notches on the ratchet for maximum application. Safety on Fiesta 96 was a major consideration at the design stage. Apart from the inherent strength built into the body structure, occupants are protected in a frontal impact by a substantial cross-vehicle beam positioned between the A-pillars in similar fashion to Mondeo. There are also shock-absorbing crash cones positioned in front of each side frame rail. Inside Fiesta, a driver's airbag housed in the steering wheel boss is a standard feature. A second passenger airbag is also optionally available. In a side impact, strong bars in both front and on 5-door models, rear doors give good protection. To add to this, the B-pillars have been strengthened. A unique safety feature is that there are now foam cushions inside the trim panels of the driver and front passenger doors. In the event of a side impact, these cushions push seats, and therefore occupants, sideways, so limiting the effect of any impact. A further new design is the pyrotechnic seatbelt buckle tensioner. In an accident, this buckle will tighten the seatbelt to help hold an occupant safely in their seat. Security on Fiesta 96 is another area that has received considerable attention from the designers. Central locking, including double locking, is optionally available. In addition, remote control locking can be specified. Here, the infrared receiver is located above the rearview mirror in the vehicle. Another option is PATS, the passive anti-theft system. Here, the engine can only be started if the code transmitted from the PATS ignition key is identical to that stored in the PATS electronic memory. If not, the engine can't be started. The radios in Fiesta are not only new. A major theft deterrent is the removable part panel, which, once removed, disables the radio and reveals a flashing diode as a warning. The electrical system on this new Fiesta will be largely familiar. The battery is housed under the bonnet on the left-hand side of the engine compartment in both left and right-hand drive models. So too the main fuse and relay box. This is located behind the battery on the bulkhead. The vehicles are fitted with a conventional wiring loom, which includes the latest type of electric plugs and connectors. The headlamps are a new design, known as the complex shape, giving excellent light output and directional throw. High beam bulbs are the familiar H1 type, low beam a new H7 type. When high beam is selected, both are illuminated. As to the locations of Fiesta's electronic modules, Mk4, as we've seen, is housed beside the left-hand A-pillar, the opening beneath it giving access to the safety switch. The security module, controlling both double locking and the alarm, is located beside the right-hand A-pillar. The airbag module is located under the passenger airbag and accessed via the glove compartment. As we've seen, the ABS module is located under the bonnet as part of the ABS assembly. And finally, the data link connector through which FDS can diagnose all these modules is located at the bottom of the left-hand A-pillar. As with all Ford European product, protection for the environment played an important part in designing the new vehicle. A very high percentage of Fiesta's steel, aluminium and plastic materials can now be recycled. All brake and clutch friction materials are asbestos-free. Fiesta's paint finishes are all water-based. The optionally available air conditioner is similar to the one fitted to Mondeo. It uses CFC-free refrigerant. And for those who suffer from hay fever, there's a pollen filter which can be specified at purchase or fitted later in service. The new 1996 Fiesta, continuing to set the highest standards in the European small car market. In this second part of the programme, we'll take a look at the principal design features on the four Fiesta engines. The Endura E 1.3-litre petrol engine includes a number of changes that make effective electronic engine management that much easier. The inlet manifold now houses the injector valves for the sequential multi-point fuel injection system. The plastic inlet manifold has been carefully shaped for optimum airflow and swirl. The throttle housing unit is bolted directly to this manifold. The engine is fitted with electronic ignition, and the ignition coil is bolted to the left-hand side of the block. There's a camshaft position sensor located in the engine's front cover. As part of the engine's emission control, there's a HEGO sensor fitted directly into the exhaust manifold. There's also a catalytic converter bolted directly to the manifold outlet. This ensures that both components heat rapidly to their ideal operating temperature. Finally, the oil pan is part of the structural strength of the powertrain, and its gasket is now a one-piece design. As with the Endura E, the Endura DE 1.8-litre diesel looks familiar but features a number of key design changes. The belt driving the injection pump is new, being both very durable and especially silent. On top of the fuel injection pump, there's a fuel lever position sensor similar to that found on the 1.8-litre diesel in Mondeo. The glow plugs are the latest slim type and have a very short heating up period. For the first time, there's a crank position and speed sensor that reads a pattern off the front face of the flywheel. There's a new crankcase ventilation system. Hydrocarbons are channeled to a filter which removes oil traces before the residue is fed to the inlet manifold. Finally, there's an EGR system which you should be familiar with from other Ford engines. The new Zetec SE engines are almost identical in design, so we'll just look at the smaller 1.25-litre unit. At the front of the engine there's a single poly V-belt, tensioned by a mechanical tensioner that drives all engine ancillaries. Two covers protect the timing belt. The belt provides the drive between the crankshaft and the two overhead camshafts. It's a long life type, which only needs changing every 150,000 kilometres. A hydraulic tensioner maintains the correct belt tension at all times. The inlet and exhaust camshafts drive 16 valves through mechanical bucket tappets. On these mechanical tappets, valve lash is adjusted by means of adjuster shims of appropriate thickness. Adjustment is only required every 90,000 kilometres. The engine is notable for its light weight. Many components, in particular the cylinder head and cylinder block, are either made from aluminium or other lightweight materials. Marginally different cylinder heads are fitted according to the engine's cubic capacity. Valve angle is asymmetrical, the smaller exhaust valves being inclined slightly further than the larger inlet valves. The surface of the cylinder head cannot be reworked. The cylinder liners are the centrifugal cast iron type and cast directly into the aluminium block. The engine is fitted with a G-rotor type oil pump driven directly by the crankshaft. Cylinder block stiffness is helped by the deep-drawn sidewalls and an unusual design for the main bearing caps. There are 5 main bearings to ensure smooth, vibration-free running of the crankshaft. But all the bearing caps are part of a single main bearing cap assembly that bolts directly to the block. These crankcase components cannot be replaced or repaired in service. If required, the complete crankcase must be replaced as a unit. Engine oil and filter replacement depends on vehicle operating conditions, but is required at least every 15,000 kilometres. The fuel injectors are located in a fuel rail that's fixed directly to the cylinder head above the inlet channels. Fuel injection is sequential. The channels of the inlet manifold are shaped to promote optimum air flow and swell to help quick mixing with the fuel. The venturi of the throttle housing unit, which is bolted to the manifold, varies in shape according to engine size. The electronic ignition coil is bolted to the rear of the cylinder head. As to emission controls, the HEGO sensor is screwed directly to the top of the exhaust manifold, and a close-coupled catalytic converter located beneath the manifold. The positioning of both ensures they rapidly reach their ideal operating temperature. All these engines for the new Fiesta have electronic engine management controlled by the powerful Mk4 module. As we've seen, this module locates beside the left-hand A-pillar on both left and right-hand drive vehicles. Beneath the module is the data link connector for FDS 2000, which should be used for all diagnosis in the workshop. To carry out diagnostic work with FDS, a CPU must be used as a translator between Mk4 and the portable diagnostic unit. In this third part of the program, we'll take a look at any new or unusual procedures you may need to know about when dismantling this new Zetec SE engine. With so many components made of aluminium or other lightweight materials, the high-tension lead cover, the cylinder head cover, the head itself, the block and oil pan. Each must be handled with great care. Many bolts in the engine can only be used once, and all have to be tightened to their precise torque. As to dismantling the engine, if you need to remove the poly V-bolt at the front, perhaps to change it or access one of the ancillary components, you must first mark the belt's direction of travel. The automatic belt tensioner can then be moved to one side against its spring so that the belt can be removed. This frees the tensioner itself and any ancillaries. To reach the timing belt, both the water pump drive pulley and the idler pulley must be removed. This frees the upper timing belt cover and engine mount. The water pump can be removed without disturbing the timing belt if necessary. An interesting design point is that the vanes of the water pump's impeller are made of plastic, so that they can be formed in an ideal shape. The pump is sealed and must be replaced as a unit in the event of failure. Jobs like replacing the crankshaft front seal mean removing the timing belt first. To loosen the fastening bolt of the vibration damper, the crankshaft must be prevented from turning by using the familiar holding tool. To remove the damper, you'll need to use a new special tool. The shoulder of the damper's securing bolt locates against the special tool so that as it's unscrewed, it pushes the damper free. This enables you to remove the lower timing belt cover. Before the belt can be taken off, you'll have to slacken the tensioner. This is done by first compressing it to a point where a 1.5mm drill bit can be inserted into the alignment bores. This will hold the tensioner in its compressed position. The timing belt can now be removed, and the tensioner unbolted, still in its compressed position. There are two further components in the belt drive, the inner belt cover and the anti-skip device that stops the timing belt from jumping the teeth of the crankshaft gear. The front engine oil seal can be removed using the universal seal remover. To fit a new seal, you'll need to use an available installer. At the top of the engine, there's good access to the high-tension leads and spark plugs once the protective cover has been removed. Removing the cylinder head cover enables you to reach the camshafts. To untighten the camshaft gear fastening bolts, the shafts must be held with a spanner to prevent them from rotating. The gears have no keyway or other means of fixing their position. They're merely a slide fit. The front bearings house oil seals. These can be removed using the universal extractor. To fit new seals, you'll need to use a familiar installer. The camshaft bearing caps are numbered for easy identification during assembly. The E prefix refers to the exhaust cam. The I to the inlet cam. When removing the camshaft bearing caps, each bolt must be released in small steps. And in the specified order that's laid down in your service literature. Although both camshafts look very similar, the exhaust camshaft has an extra lobe for the camshaft position sensor. In addition, the 1.25 and 1.4 litre camshafts are distinguished by either one or two cast rings. The bucket tappets are mechanical, each having a shim that can be varied in size to adjust valve lash. If being dismantled, these tappets and their shims must be stored in such a way that they can be assembled in their original positions. When untightening the head bolts, engine temperature must be less than 30 degrees centigrade. The bolts should then be untightened in small steps and in the order laid down in your service literature. This avoids any chance of the aluminium head distorting. It's also a sensible precaution to store the head on a rubber mat to protect its sealing surfaces. The cylinder head gasket is a multi-layer type and can't be reused. The gasket for 1.25 litre engines is distinguished by 2 lugs, that for 1.4 litre units by 1 lug. If you have to replace the rear engine oil seal, the flywheel must first be removed. To stop it from rotating, a familiar crankshaft blocking tool can be used. The rear engine oil seal is integral with the rear flange, and so has to be replaced as a unit. Pistons can be removed in the usual way. Should you do so, you'll find that each connecting rod and bearing cap have cracked surfaces. These guarantee a very precise fit and ensure that only the two correct components can be assembled together. Each piston top is marked with an arrow that should point to the front of the engine when the piston is in place. As we've seen earlier in the programme, the crankshaft is supported in 5 main bearings. These bearings are built into a main bearing cap assembly, which helps to create a very solid crankcase. Because of the very close production tolerances, the bearing cap assembly must not be removed in service. In fact, there's no need, because the crankshaft can't be overhauled or replaced, and the cylinders can't be rebored. Should the need arise, the complete crankcase has to be replaced. Assembling this Zetec SE engine is not a complicated business, although there are 1 or 2 points you'll need to remember. At the bottom end of the engine, a small amount of specified sealer must be applied to 3 areas on the block face before the oil pan and its gasket can be replaced. The old gasket must not be reused. And before tightening the oil pan down, it must be aligned to the block. Thereafter, the bolts should be tightened in stages and in the order shown in your service literature. When you come to assemble the flywheel, its correct position on the crankshaft is guaranteed by a locating dowel. This is necessary because of the crank position sensor, which reads a particular pattern on the front face of the flywheel. Before fitting the cylinder head, the piston in cylinder number 1 should be set to about 25 millimeters before top dead center. While these cylinder head bolts can be reused, as with most cylinder heads and aluminium ones in particular, you must precisely follow the tightening down procedure given in your service literature. Before starting to fit the tappets and camshafts, you must check that piston number 1 is still about 25 millimeters before top dead center, and this is confirmed if the flywheel locating dowel still points to about 5 o'clock. The bucket tappets and their individual adjustment shims must be assembled back into their original positions. As to the camshafts, these should be positioned so that none of the cam lobes point directly down onto the top of a tappet. A small bead of sealer should be applied to the mating surfaces between the cylinder head and 2 front-bearing caps. Thereafter, all the bearing caps can be positioned and tightened down in small steps to the correct torque and in the order shown in your service literature. New camshaft oil seals should be fitted, and then the camshaft gears, leaving their securing bolts just finger tight so the gears can spin free. The camshafts should then be aligned to the position they would be in with piston number 1 at top dead center. This is done with an existing alignment tool that fits into the slots at the rear of each camshaft. Then piston number 1 must be set precisely to top dead center, and this is done by inserting an alignment peg in the right-hand side of the block towards the front. The crankshaft should then be turned clockwise against this peg, never anti-clockwise with the peg in place. Before fitting the timing belt, the inner belt cover, the belt tensioner still compressed by the 1.5mm drill bit, the crankshaft gear, and the anti-skip device should be assembled. Fitting the timing belt begins at the crankshaft gear. Make sure the belt's direction of travel is correct and work it into place in an anti-clockwise direction. Once in place, the drill bit should be removed from the belt tensioner. Assembling the lower timing belt cover and then the crankshaft vibration damper is quite straightforward. To press the damper fully home, there's a new special installer, because the torque required for this job exceeds the torque limit of the damper bolt. After the damper has been pressed home, a new fastening bolt should be used to secure it. Next, the camshaft alignment tool and the crankshaft alignment peg should be removed. When torquing the camshaft gears to specification, they must be stopped from rotating by the familiar holding tool. Valve timing should now be rechecked by first turning the engine nearly 2 full turns. Insert the crankshaft alignment peg and then turn the engine the remainder of its 2 turns so that it rests against the peg. At this point, the camshaft alignment tool should fit easily into the slots at the rear of the camshafts. If it doesn't, the fastening bolt of the affected camshaft gear should be slackened. The camshaft can now be turned to allow the alignment tool to fit. After tightening the camshaft gear, the camshaft alignment tool and the crankshaft alignment peg should be removed, and a further check made on valve timing, beginning with turning the engine over nearly 2 full turns. When fitting the engine cover, note that the gasket is vulcanized onto the aluminium cover and cannot be replaced in isolation. However, replacement of the cover depends on the gasket's condition. It should not automatically be replaced after every removal. The rubber grommets for each securing bolt can, however, be replaced individually. The securing bolts must be tightened in small stages and torqued to specification. In this final part of the programme, we'll take a look at the engine management system for these new Zetec SE engines. As with other European Ford vehicles, the electronic engine management module is the powerful Mk4, capable of processing an astonishing 7 million instructions a second. The module locates beside the left-hand A-pillar on both left and right-hand drive vehicles. As is usual, a range of sensors monitor key functions in the engine, among the principal ones being a mass airflow meter that keeps Mk4 informed on the air drawn in by the engine. It locates next to the air filter housing. The throttle housing unit, which bolts directly to the air inlet manifold, includes a throttle position sensor. There's an engine coolant temperature sensor. This locates at the rear of the engine, beneath the electronic ignition coil. The temperature of the inlet air is monitored in isolation from the mass airflow meter by a sensor located in the air filter housing. There's a familiar crankshaft speed and position sensor. This reads a pattern off the front face of the flywheel and locates at the rear of the block. Another familiar sensor is that reading the camshaft position. It locates in the side of the cylinder head, reading the lobe on the front of the exhaust cam. The EGR system includes an exhaust gas recirculation pressure transducer. It locates on the engine compartment bulkhead. And another emissions-related component is the HEGO sensor. This locates in the top of the exhaust manifold. And finally, there's the power steering switch, which signals Mk4 to vary engine speed according to power steering fluid pressure. Information from both engine and transmission-related sensors is constantly relayed to Mk4. The module computes and compares it to map data, and then sends out signals to a range of actuators. These include the injectors in the sequential fuel injection system, the electronic ignition coil, the idle speed control valve, the solenoid of the EGR vacuum regulator, and the solenoid controlling the evap canister. Finally, a key feature of this latest Mk4 system is that the module can be reprogrammed. The new EEPROM can be cleared and programmed using the latest engine management programs with the aid of FTS 2000. Advanced vehicle technology from Ford, setting new standards in the highly competitive European car market.